So as we continue on, we're now really hitting the chorus 19.1, which is truly we're getting into what we call right triangle trigonometry. So we get into trigonometry, we're going to start to look at relationships between sides and angles. And to do this, we have talked about this language. We have now the these angles of a right triangle. Notice how we have C is actually the right angle, and then A and B are going to be the adjacent angle or the acute angles. So notice how if we talk about angle A, notice that if we're talking about this angle here, this bottom edge is going to be adjacent to A. Again, this is going to be the hypotenuse. And over here is going to be the side opposite of A. So that's some things we need to start picking up on this word adjacent, opposite, and hypotenuse. So if we're talking about angle A, the side BC is going to be opposite of A. Side AC is going to be adjacent to A. And then AB is going to be the actual hypotenuse. So again, if we look at this same triangle, but now if we look at it from the perspective of angle B, notice that now this side becomes the adjacent side. It's next to B, where over here is now the opposite side, but the hypotenuse remains the same. So depending on what acute angle we're talking about, the adjacent side and the opposite side will be different. So we have to pay attention to what angle we're talking about. So again, opposite just means you're over here on this other side. Adjacent means you're actually sharing that side with it. So we have that kind of going on. So we have adjacent, opposite, and hypotenuse. So as we move forward, we'll start to pick up on some other vocabulary. So when we get into trigonometry, we have these words sine, cosine, and tangent. These are going to be some special functions. And a lot of times they're abbreviated as SIN for sine, cosine is COS, and TAN is for tangent. So a lot of times we're going to use letters to designate the sides of the standard right triangle. So like we were doing up there, we're going to be using letters to identify the sides of the right triangle. So in a standard right triangle, you know, we're going to have the side A is opposite of angle A. So notice how little a is going to be opposite of angle A. Side B is notice how it's going to be lowercase, is going to be opposite of angle B. And then side C is going to be the hypotenuse, and it's going to be opposite of angle C. So if I look at this triangle ABC, notice how there's angle C. Notice that the hypotenuse is opposite of angle C because angle C is the right angle. Now, if we're talking about angle A, notice that in angle A, side A is over here, and it's going to be opposite. And B is going to be adjacent to angle A. So if we use this relationship, what we pick up on is the sine of A is defined as the side opposite of angle A over the hypotenuse. So in other words, A over C. The cosine of A is actually going to be the adjacent side of angle A over the hypotenuse. So that's going to be B over C. And then the tangent of A is defined as the opposite angle of A over the side adjacent to angle A. So that's going to be the adjacent over the opposite over adjacent, I should say, A over B. So again, A refers to that acute angle. So you're taking the sine of an angle, and over here, it's going to be a ratio of the sides. So to write trigonometric ratios for a right triangle, given the measure, we have to know at least two sides. We can do that. So identify the acute angle to start with. That's important. We identify the hypotenuse, opposite side, and adjacent side in relation to that angle that was given. And then we want to write the appropriate trigonometric ratios. So we're going to write the sides in forms of ratios. And we may have to simplify the ratio or convert it to a decimal equivalent if necessary. So if we want to find sine, cosine, and tangent of angles A and B, again, leave the answers in fraction forms. So if we want to find the sine of A, remember it's going to be, here's A over here, it's going to be the opposite side over the hypotenuse. But notice how they put the hypotenuse in feet and inches. And this is in feet, and this is in inches. So the catch is we got to have everything in the same unit of measurement. So here I'm going to probably just convert everything into inches. So 2 feet would be like 12, and 12 would be like 24 inches. And here this would be like 25 inches. So it makes better sense here to convert everything into inches. So the sine of A is going to be the 7 inches over the 25 inches. And that doesn't reduce. The sine of B is going to be the adjacent, which is the 24. I'm sorry. Back up here. Let's stay with the same angle. So the cosine of A is going to be the adjacent, which is the AC, over the hypotenuse, which is 25. So that's going to be a 24 over 25. The tangent of A is going to be the opposite over the hypotenuse. So if I clear this up a little bit, again, if we're talking about angle A, again, we said this is actually 24 inches, and this is actually 25 inches, because we want everything to be in the same unit of measurement. Otherwise, we can't make any math out of it. So again, 7 is going to be the opposite, and the 24 would be the adjacent. So if we pick up on that, so we'd have that. Now, if we do the cosine of, I'm sorry, the sine of B, get ahead of myself here. Let's just keep it in order. So if we're doing the sine of B, now we're up here at this angle. Notice now the 24 becomes the opposite and the 7 becomes the adjacent. So if I'm doing the sine of B, the 24 is the opposite. The 25 is still the hypotenuse. If I'm doing the cosine of B, notice the 7 is now the adjacent and the 25 is the hypotenuse. And if I do the tangent of B, it's going to be the 24 over the 7. So 24/7 would be the ratio there if we leave them as fractions. So if we want to find the sine, cosine, and tangent of angles A and B, express the answers in decimals, round the answers to the nearest 10,000th. So that means 4 decimal places. Probably need to get our calculator out for this. Let's just slide this over. Make this a little bit bigger. So again, let's start with respect to angle A to start with here. So if I want to find the sine of A, that's going to be the opposite over the hypotenuse. That's going to be 5 over 15.81. So if we do that math, 5 divided by 15.81. So if we round that to 4 decimal places, that's going to be 0.316. And that 4th place is going to actually have to change to a 3 because of that 5 there. If I do the sine, the cosine of A, the cosine of A means, again, we're talking about A still. Now the 15 is what we're focusing on. That's the adjacent. And it's going to be over the hypotenuse, which is the 15.81. So I'm doing 15 divided by 15.81. So it's going to be to the 10,000th place. Again, 4 decimal places. That's the way it was back in the day when I was using tables, is they were 4 decimal places. So I guess that's why they're doing it this way too. So that's going to be 0.948. The 7 is going to change to an 8 as well. So then if I do the tangent of A, the tangent of A is going to be the opposite, which is the 5 over the adjacent, which is the 15. So 5 over 15. So that's just 1/3. That'd be like a bunch of threes, 0.33333. 5 divided by 15. So this is going to be 0.33333, 4 threes. So if I look at now angle B, so the sine of B, if I want to create the geometric ratio, that's going to be the opposite over the hypotenuse is going to be 15 over 15.81. We've already done that math. That's going to be 0.3163. The cosine of B is going to be the 5 over the 15.81. And we did that. That was up here. Oops, I got that wrong, didn't I? Sorry about that. So the 15, how did that take off on me? It took off in a hurry, didn't it? So 15 over 15.81 is actually the 0.9488. And then the 5 over 15.81 is the 0.3163. And then the tangent of B is going to be the 15 over the 5. So that's going to be actually just 15 over 5, which actually would be 3. So that'd be our ratios there as needed. So we have these special ratios that come into play with trigonometry that helps us solve a lot of problems here. So back in my day, we had to use tables, but here we have a calculator. So to do trig on your calculator, make sure your mode make sure you're in the right mode when you do this. So if I'm looking at this, if I want to find the sine of 27 degrees, notice that I want to be in degree mode. So if I change my mode, notice how it's already in degrees, so I can go ahead and just do that as is. So notice that we have our sine buttons are here. Sine, cosine, or tangent are right in the middle of our calculator. So if I hit sine and type in 27, we know that's in degrees already. That's going to give me this point. Again, they're doing it like 4 decimal places. So 0.4539. So it's going to be like 0.539, and that's just going to turn up to 40, 0.540. So sine of 20 degrees, 30 minutes. So if it's sine, if I do again here, 20, hit the second button angle, choose number 1, and then 30, second angle, choose number 2 for minutes. If I do that, that'll also give me our measure. So that's going to be 0.3502 would be that. Now, for this one, since this is no degree symbol, this means this is understood to be in rads or radians. So if I change my mode here to radians and then quit, if I do now cosine, if I do 1.34, that should be radians now. That'll give me this 0.22878. So 8 actually. That 7 would round up to an 8. So then we have the tangent of pi over 4, and that's going to be in radians as well. So if we hit 10 and if we hit the alpha button, we actually can just use division. Second pi divided by 4. We don't have to get too crazy with that. Hit enter. That'll give me 1. So pi over 4. Pi over 4 is actually a 45-degree angle. That's going to be a 1. So remember, in a right triangle, the legs of a 45 are the same. So that will give me a ratio of 1. So got that going on. Now, Another thing you can do on your calculator is you actually can use these ratios to find the angle measure. So this is where we have this inverse sine, inverse cosine, and inverse tangent. So if I want to find the angle, what I can do is do the inverse sine of 0.6561. Now notice though it wants the answer in degrees, so I have to change my mode back to degree measure. Change it from radian back to degree. So now if I do the inverse sine, so inverse sine is the blue one. Inverse sine, if I put the ratio in as a decimal, 0.6561, that'll actually kick out the degree measure. So it'd be like 41 degrees. And notice how they say round to the nearest tenth of a degree, so that's 1 decimal place. So that'd be like 41.0 degrees. So again, if I want to find the angle, I can use the inverse cosine. So inverse cosine will work it backwards and actually find the angle that's associated with that, 0.4226. And that would give me 65.0, or about 65 degrees. So inverse cosine of 0.4226 would give me the angle, and that would be 65.0 degrees. If I do the inverse tangent, that'll find the degree of that one. Inverse tangent of 2.825. And if I enter, that'll give me that in degrees. So if I do the inverse tangent of 2.825, that'll give me a measure of 70 degrees, 0.51 degrees. So 70.51 degrees if I round it to the nearest. Oops, no, they said tenths place, not hundredths place. So that'd just be 70.5 degrees. So rounded to the tenths place. So we have a lot of little things we can do here with trig. We can find these ratios and we can find these angles. So the goal here is just getting familiar with sine, cosine, and tangent.